Hello everyone, August 14th. Alright, most of my stuff is gone and yeah, and now I realize that the apartment has quite a loud echo. It's kind of fun. Alright, so we have an easy problem today, which is good because I want to revisit yesterday's problem. Because there are, I think, two more solutions that I want to go through. And we probably need to, wait, what's the problem with this one? I use union wait, hold on. Targen, yeah, this is what we need to go through, the Targens method. Okay, so I have to go through these, gosh. All right, so let's do today. Oh, and one more thing, I don't have my pad to write things anymore, so it'll be a bit challenging. I don't have a pen and paper. I think I packed everything. It's a bummer. All right, let's take a look at this. At a lemonade. Water. Each lemonade costs $5. Customers are standing in a queue to buy from you and order one at a time. In the order specified by bills, each customer will only buy one lemonade and pay with either a $5, $10, or $20 bill. You must provide the correct change to each customer so that the net transaction is that the customer pays $5. What? I just need to prepare a change. Know that you do not have any change in hand at first. Given an array of bills, where bill's I is the bill the ith customer pays, return true if you can provide every customer with the correct change or false otherwise. I guess you can just, now you can just use your simulating this, right? So we can get 5, 5, 5. So I have 5. I have 3 $5 bill. I have 2 $5 bill, and I have no 5. Wait, really? First 3 customers collect. For the fourth customer, we collect 10. Oh, we give back a 5. Oh, for the 20, I need to return 15, so I get a 10 and a 5. Got it. This is false because I have 2 $5, I have 1 $5 and a 10. I have 0 $5 and 20, and I cannot do it. So the bill is either 5, 10, or 20. So I'll basically keep a counter. If you give me 10, I have return 5. If you give me 20, I have return of 10 and a 5. Just keep going like this. All right, so nothing special on this one. We can just go ahead. Blow it out of the way. We don't have to worry about this anymore. Okay, let's do this. All right, so what do we have? What do we need a counter? We do need a counter, but I can do a counter by just say, yeah, I think this one will be easier. 21, okay? For int B in bills, right? If B is equal to 5, then we do counter 5 plus plus. Else, if B is equal to 10, and counter 5 is larger to 0, right? Then we say counter 10 plus plus and counter 5 minus minus. Else, if B is equal to 20 and counter 5 is larger than 0 and counter 10 is larger or equal to 0. right? In that case, then we do counter 10 minus minus, counter 5 minus minus, and a counter 20 plus plus. Else return false. Otherwise, return true. Yep, I think just by simulating the whole thing, we're good. 860. Simulate the entire transaction. Okay, let's take a look. Got it. Submit. What? Oh my. Oh my. Expected true. That is. Oh, I see why. Oh my goodness. Yep. Oh. All right. Yeah. I see. Ah, damn it. All right. So, counter. Yeah. So 5 is larger than 0 and counter 10 is larger than 0. Yeah, my bad. This is completely my fault. I forgot there are 2 ways to do this. Else if counter 5 is larger. So that just means if we don't have a 10, if I have a 10 and I've had a 5, we're good. So we need to make 15, right? So either 10 and a 5 or 5 is larger than 3, right? Then we say counter 5 minus equal to 3. Yep. Yeah, that was an oversight. That was totally an oversight. I forgot there are 2 ways to make it. Huh? Wait, what? The second one. Oh, it's an S, else. Man, can we, I don't know, can we make it? And this is actually greedy because we try to check for 10 first and then check for this. I think it should work. It just said it should work. Larger equal to 3, my bad. That was a typo. There you go. That was just a typo. The second error was just a typo. The first one was wrong. Second one is fine. Okay, so we're done with this. We can take a look. How it look like? Yeah, simulation. Okay. All right, so this is yesterday binary search for my solution, and we're counting. So let's see if there's any better solution. DP, okay. Yes. Yes. For any given distance, we can count the number of pairs less than or equal to d. So for me, it's a binary search on top of binary search. And this one has a prefix count. Prefix count I represents the number of elements less than or equal to I. Value count, the count of occurrences of the value I in the array. A number of elements within distance, number of pairs formed by duplicate occurrence of x using value count. So we can avoid another binary search. Prefix count. What's this value? Possible distance. So basically, keep incrementing the index until we have some value that's bigger than the distance. And prefix count. Prefix count value. It's to compute given the current value, right? Given the current distance, I want to know from the front, okay, from the front, how many pairs? Hold on, I still don't understand. What this one does? The cumulative count of elements up to each value in a sorted. For any index I, the cumulative count of elements up to each value. I don't understand. Prefix count. This index is basically just because index is smaller than array size, and num's index is smaller or equal to a value. So if I have a current distance, and just go up until a point where num's index is larger than value, then I say prefix count. So that's the number of values, right? The number of values smaller than the number of, not values, the number of values smaller than the current value. And indexes keep going. Huh? What does this prefix value do? Nice. Do we have this count pairs? What the hell? Maintains the cumulative count of elements up to each value in the sorted array. Yeah, because this is equal to index, right? We just say the grade. Up into this value, how many numbers in the array is smaller or equal to this value? Right, I go up, maybe the same. Okay. Yeah, so this is how many that's smaller or equal to this. How does this help? How does this help? Yeah, I know how many is smaller or equal to this. Okay, then given each, because I have a mid, right, count. Okay, this part is very easy. So count the pairs with distance smaller or equal to mid. Count the distance that's smaller or equal to mid. Maybe we can simplify this, right? Maybe we can simplify this. Yeah. Why don't you simplify this? We just do mid. We don't do this. Right, we go through this so we get count once. And if including count is smaller, then we do this. Else, we do this. Does this one work? Oh, screw this. Yeah, it works. Don't understand why you make things so much more complicated than it's supposed to be. Right, and that's including the tough test case. Well, technically it's O n log n plus n log m. sort, and then here is log m times log n. So I'll say plus n. Yeah, there we go. It's much better, right? It's much better. That's 39 milliseconds. It's much better. So you only need to do it once. Yeah, I don't understand why I feel the necessity to do the other way around. Right? It's really not necessary. You do have to do this. Okay, now we go back here. How do we make the count? So I have the distance, right? Then you go through one by one. So for each one, you need to count, right? The count. And I can go there to count how many is smaller or equal to this. I do the current plus, right? Plus. So yeah, that's why you need 2 times. Basically, I can say I have a count of how many people, how many values is smaller or equal to any result. So we add that. So again, how many is smaller or equal to that? And then we do that. So everything in the middle is the count. Current value for count, right? Pairs, they're equal to that's correct, minus current value. This is with larger values. Pairs with larger values. Pairs with same values. Pair with same values. Why do you have to go through all this complicated? Because what I'm saying is I'm counting the number that's smaller to a certain value, right? If I'm counting that, to this, if I add it to it, right, then, yeah, why do I have to be so complicated in this? Because all I'm doing is trying to find the number of current value plus max distance, right? This tell me how many is below that. Yeah, well, include all the duplicates, right? And we have how many is smaller than that? Yeah, current values is something smaller equal to that. And everybody in between. But then pairs with larger value, with same value. What do you mean by pairs with same value? Oh, because we're trying to find the ones bigger, and then we need to find things with the same value. I see. Okay, so we need to know How many is the same? So it's minus 1. Ah, yep. Value count for current times value count for current minus 1 divided by 2. That I do not understand. What the hell is that? Pair is same value. What? Value count for current. Oh, because all of them. That's not pairs with same values. It's just. Wait, hold on. I still don't understand. Value count for current. Value count for current minus 1. It's larger value times value count for current plus. Huh? So we have all those, which is what we compute with that pairs with larger values. Okay, we get all the ones with larger values. Okay, we get all with the larger values. That's fine. Value count for current. Value count for current. Oh, value count. It's not prefix count, my bad. Okay, I got it wrong. Yeah. This is a prefix. Prefix count. Okay, this is good. Value count for current. Okay. Yes. So this is for the zeros. Value count for current. And because we do that, right? Then we do that. And I guess that is correct. Yep, that's correct. That's the pair the same. Okay, yeah, I got it. And then it's value count with current times that. Yes. Yep. That is correct. And we skip all this. Okay. Okay, I see what it's trying to do. Nothing too special. I don't think I'll try it for this one. Let's try this one. Sliding window. So what does sliding window do? You have a sorted sliding window. Okay, we have a left and a right. While nums right minus nums left is larger than distance. So we keep moving the left until it's smaller or equal to. Then add the number of valid pairs. Oh, you are kidding me. You are kidding me. A number of pairs. So we have a full range, right? We have a full range. And then we're saying that we have that many pairs.
There's something wrong with the spreadsheet. Put 16 and made this. So put below 16, it's fine. But I should be able to put 5 additional reps because I did it for the week before. And percent would also beat by 5 plus reps. If I put 16 and there's an error. And that one.
And that's the 15. Quick step. M74.
Is a typo somewhere?
Because if you compare to this, right? I don't see any typo. So D of 15, setup df15, quick setup a2. Quick setup is the same. So the only difference is
BT.
yeah, BT28 is BM28. BFMT, right? This is DR, this is DF15. Yeah, BT28 we saw it, it's just it's a number. It says unresolved sheet name. Huh? It's interesting.
That's not real.
Resolve the sheet name.
Isn't there an option to expand it? So it shows exactly what it's calculating.
Yeah, you cannot do on the, because this is not,
Oh, Excel.
this is Excel, but it's not.
Oh, it's Google Sheets, not Excel.
Google Sheet has this as well, but it's we're across. We're doing things across separate.
It's fine, you can do it later.
No. Quick setup A2. Hold on. Okay, this quick setup A2 is not a problem. See, they can't even handle BT28. It's something is wrong in this cell. Something was wrong with all these cells. The problem is with BT28. Let's see again. The problem is with BT28.
You can take it out, there's no issue.
No, BT28 has issues as well. BV20. Hold a second. Let's put this one back. You said if you put 15. Okay, so 15 things are working, but 16 things are not working.
And it should work because it has option B by 5
Q29,
plus
BQ20.
rep.
Oh.
Oh, that's where it is.
Crap. Oh, I'll take a few digging here.
No,
Alright.
just look for the typo.
Here. Got the typo.
That was fast.
There we go. But I am pretty sure. How do I hide this? There we go. I'm pretty sure it will face similar problem in the future because I believe I might have copy and paste something and then
Oh my god. Why don't you put greater than 6?
we'll deal with it when it happens. You're welcome. So where are we? We're trying to add. So we have a window, right? And we're computing the number count pairs with distance using a sliding window. So we'll move to the first one that it's smaller equal to distance, right? So this within is smaller equal to distance. Then everything within is smaller equal to distance. Then we count right minus left. That's the total number, okay? That's starting with this. Just starting with this is the total. Now we move forward. Right, right move forward. If become too big, then we move forward. So basically we're saying starting from the left, how many can we do, right? Once we finish, we cannot move more to the right. So we move to the right, then move left. And if the right is too big, we just keep moving. The sliding window. The sliding window solution is the right solution. Alright, so yeah, we can do it here. So this is the binary search with let's just get yesterday's out. This is yesterday, and I'll count this as solution 1. Okay. Get count. Int dist. Count the number of number of pairs in nums whose diff is no bigger than dist. Here we use sliding window technique. For a window, low to high, nums low to nums high, we find the total number of pairs starting with nums low, right? Where nums low nums high minus nums low is largest possible. That is not bigger than the total number, right? Total number of pairs starting, actually. That's the total number of pairs that start from nums low is high minus low minus 0, 1, 2. Okay, so 0 and this, how many? Yeah, that's that. Okay, so here's what we're gonna do. While right, and then we return res. Yeah, we make sure high minus low is larger than the this, then we move. If it's not, then we just keep adding, right? If it's not, if it's small, then we just, add it, and we move high forward, move high forward, move high forward. Every time we move, then we'll add this. That's just not, hold on. We need to move it, right? Because if it's good, right, given a high, wait, hold on, this is not right. This is not right. No, this is right. It's larger than distance, right? Yeah. No, it's not. Thanks. The n of them high, because each time we'll move high. Okay, each time we'll move high. We move high to a certain point, and we have to count how many pairs ending at num high, right, is good. So we do that, it's good. Move to the next one, and then we move the left, move the low to a certain point where we find the biggest, the maximum distance that's smaller than the max. It's smaller than smaller equal to than the current dist. Then we do it. Move forward. Yeah. Oh, this is brilliant. Yeah, this is brilliant. Sliding window. So now with that, become very easy. The binary search plus sliding window technique as demonstrated in the official solution. Do this, do this, do this, do this. Int count shall equal to get count nums. What is distance? There's no distance. Distance is mid. Okay. Delete, 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 delete them all. And we say if count is smaller than this. Else, I don't even need this. Alright, so delete, delete. Else high equal to this. We delete everything. Yeah, so we do the count, right? We say we include everything. If it's bigger, if it's smaller than k, then we have to make it bigger. If it's larger or equal to k, we try to move left. Because if it's equal to k, we can try to move to the left, and then everything will be good. Okay, that's that. Let's submit this one and call it a day. Make sure you run everything first. Looks good, and this should be fast. Oh, 8 milliseconds. Five times faster, and 7 times faster. Oh, Lord, it's good. It's very, very good. Yeah, it's clear. It's very clear. This is O n log n plus m log n with no overhead. All right, good, very good. Oh, actually, I think this is a good problem for interview. I might use it. Good interview problem. Because we have at least 2 different ways to solve it. And then I think there is a brute force. But yeah, I'll let it slide. Okay, that will be it. I'll see you guys tomorrow.